All right, guys, this is Mr. Ainsworth, and we are going to get into review number 2 here over growth and decay functions, exponential growth and decay functions. So let's start off with the growth function with base 3. Notice right here we got base 3. Now, whenever you have a base bigger than 1, in this case base is equal to 3, you have a growth function. This is when the base is bigger than 1. And it looks it's going to look very familiar. So let's take a look at the domain. Let's take a look at it from -3 to 3. Remember, this set of x values is called the domain. What you get out of the function is called the range, or the output. So let's do all our work. Let's show all side work here. And let's step it out, okay? Here we go, -3. So what happens? What's 3 to the -3 plus 2? So 3 to the -3, all right, plus 2. What is that? Well, this becomes a fraction. It becomes 1 over 3 cubed, all right, plus 2. What's that? Well, let me see. We know that in terms of powers of 3 here, 3 times 3 times 3 is 9 times 3, or 27. So this is actually 1/27 plus 2 more, which is just 2 and 1/27. All right, so once again, I want you guys to step it out. Let me write that big, bold, and red. Step it out. When we take our test next time, I want to see your thinking. Okay, so step it out from here to here, and from here to here. I want to see your thinking. So we got a first point here, -3 comma 2 and 1/27. What is the function evaluated at -2? I don't know. Let's figure it out. So at -2, you got 3 to the -2 power plus 2. Well, this becomes a fraction, 1 over 3 squared, but you still have to add 2. What does that become? It becomes 1/9. 3 squared is 9, plus 2, or 2 and 1/9. So my next order pair is -2 comma 2 and 1/9. So what do we get when x is -1? Let's substitute it in. 3 to the -1 plus 2 more. What does that become? It becomes 1/3. When you add 2, you get 2 and 1/3. When it's addition, it's very simple. You just add the fractional part with the whole number, and you get a mixed number. So you get -1 comma 2 and 1/3. So notice the fractions are getting bigger and bigger here. So what is it at 0? So 3 to the 0 power plus 2. 3 to the 0 power we know was 1. Add 2, you get 3. So 0 comma 3 is a point on the graph. And that is, of course, our y-intercept. All right, 0 comma 3 is on the graph, or on the axis, the y-axis, that is. All right, so keep that in mind. There's your y-intercept right there. Next point at 1, 3 to the first plus 2. It's just 3 plus 2, or 5, so 1 comma 5. At 2, 3 squared plus 2 is 9. 9 plus 2, of course, is 11. So you have 2 comma 11. And you just step it out like you normally do. So here, 3 cubed plus 2. What is 3 cubed? I already talked about that before. It's 27. Add 2, you get 29. So you get 3 comma 29. Okay, and then you're going to plot all these values. So you step it out and show your side work. You plot each point. So let's do that in red. Left 3, up 2 and a little bit. So left 3, up 2, and a teeny bit more, right above the second grid line. 2 and 1/27 is just a little bit more than 2. All right, -2 comma 2 and 9 is left 2, up 2 and a little bit. So left 2, 1, 2, up 1, 2, and a teeny bit. Okay, it's right past the grid line. -1 comma 2 and a third, left 1, up 2 and a third, a little bit higher. 0 comma 3 is right here. There's your y-intercept. 1 comma 5, that's easy to find. Right 1 up 5. 2 comma 11, 2, 4, 6, 8, 10, 11's right here. That's 11. 3 comma 29 off the grid. Okay, so I'm not going to plot that. So you want to graph or show the graph, okay? And notice all these values. Well, guess what? Because of this plus 2, I know that all of the values are going to be bigger than 2. So y is greater than 2 in this case. That's called the range, okay? This plus 2 in the function here raises your horizontal asymptote up 2 units. So I'm going to graph that. Here's my horizontal asymptote in blue. Y equals 2. Call that HA for horizontal asymptote. Okay, I know that because of this plus 2. I can see that in the graph. So when I draw the function, it approaches that horizontal asymptote and then takes off upward because of the growth function here. All right. This is 3 to the x plus 2. That plus 2 raises the horizontal asymptote from y equals 0 to y equals 2. It raises everything up 2 units. So keep that in mind. The range, y values, all y values, like look at them all, they're all bigger than 2, right? Because they're above the horizontal asymptote. It doesn't cross the x-axis, does not, or doesn't cross x-axis here. And because of that, there's no x-intercept. The domain, as in all functions or exponentials, is all reals. So keep that in mind. Okay? So what you want to do is, again, just step it out, show your side work, plot each point really well, look at what's happening to the function, this plus 2 or whatever's being added or subtracted affects your horizontal asymptote, either moves it up, like in this case 2 units, or could move it down if that was a minus sign. Okay, and all the y values are bigger than 2 because they're above the line. And not only that, just look at them. They're all bigger than 2, so the range is big, y greater than 2. That's it. All right, let's try another one. Let's take a look at a decay function. Now, a decay function is where the base is less than 1. So here, this is equal, the base is 1/3. Notice that that is less than 1. And you have a decay function. This one looks different. So let's start our domain off at -3 and figure out the range. Okay, now this one's more technical, so here's how we're going to approach it. We're going to take 1/3 to the -3 power and then subtract 2. Okay, I'm going to rewrite it in exponential or power to power form. So we've got okay, so you're going to take 1/3, raise it to the -1 power, and then cube it. When you have a power to a power here, power to a power, you guys know that we have to multiply our exponents. So this makes sense. -1 times 3 is -3. So from here to here, this is just written as a power to a power. And you have to remember that when it comes to taking a number or a fraction to the -1 power, that just reciprocates the number. So you reciprocate first, all right? So 1/3 to the -1 power is 3. Then you cube it, then subtract 2. All right, so from then right here, you raise it to a power, raise it to the power. 3 cubed is 27. All right, minus 2, well, that's just 25. Now, I'm going to take a moment here. I'm going to show you again why that happens. So let me bring up my calculator here. And we're going to take 1/3 to the -1 power, and I'm going to show you that all it does is just reciprocates the fraction. So check this out. We're going to take 1/3. We're going to raise it to the -1 power. And you should already know that the reciprocal of 1/3 is 3, and the question is, do we get 3? So here we go. Oh, look at that. We got 3. The reciprocal of 1/3 is 3, and so what this -1 power means, it means reciprocal. Okay, so keep that in mind. You want to reciprocate first, and then you want to raise it to the power and show your thinking. Again, right here, you reciprocate first, and then you evaluate or raise it to the power of 3. 3 cubed is 27, so then subtract 2, you get 25. So my first point is -3 comma 25. Then what do you get when you get -2 and so on? So let's try that. So 1/3 to the -2 power, then minus 2. So you rewrite it in power to power form. So you take 1/3 to the -1 power and then square it and then subtract 2. Okay, like I said before, you reciprocate. The reciprocal of 1/3 is 3, then square it. Now you raise it to the power now. 3 squared is 9. 9 minus 2, well, that's just 7. So my second point is -2 comma 7. Look at the steps. Reciprocate to get 3, square it next to get 9, then subtract 2 to get 7. Step it out, like I always say. And then at -1, so 1/3 to the -1 power minus 2. The reciprocal of 1/3 is 3, minus 2 is just 1, so -1 comma 1 is point on the graph. At 0, any number to the 0 power is 1, so this becomes 1. Subtract 2 to get -1. So you have 0 comma -1. Oh, and by the way, this is a video, right? So if you guys are thinking, hey, man, I can't keep up with this guy. No big deal, right? Press pause, okay? Pause and play and take yourself at your own pace. So keep that in mind, all right? At 1, you got 1/3 minus 2. That's a negative number, but you got to be thinking 2 minus 1/3, right? I've talked about this extensively. You know it's negative, so you see the negative sign. If you have 2 pizzas and you take 1/3 of one away, then 1 and 2/3 remain, but you know it's negative. So 1 comma negative 1 and 2/3. Once more, if you have 2 pizzas and then you eat 1/3 of the pizza, then only 1 and 2/3 remains, but it's negative. Now, if you take 1/3 to the second power, then square it, you got to raise it to the power first. Now, when you square a fraction, you square it parts. When you square 1, you get 1. When you square 3, you get 9. So when you square the 1/3, you get 1/9, but you still have to subtract 2. We know that's a negative number, so we put down the negative sign. And then 2 take away 1/9 is 1 and 8/9. Why? If you subtract 1 part out of 9, then 8 parts out of 9 remain. So you get negative 1 and 8/9. So 2 comma negative 1 and 8/9. And then last one, 3. 1/3 to the third power minus 2. What do you get? You get 1/27th. You cube the 1 to get 1, cube the 3 to get 27, so 1/27th minus 2 is a negative number, but you got to be thinking 2 minus 1/27th. All right, which is negative 1 and 26 out of 27, because if you take out 1 out of 27, then 26 out of 27 remain. So 3 comma negative 1 and 26/27 is a point on the graph. Now you start plotting them all. So here we go. Left 3 up 25. Okay, I won't graph, then I'll start here. Because I don't want to change the scale. Negative 2 comma 7 is left 2 up 7. That's 2, 4, 6, 8, 10, 12, 14, 16, 18. So left 2 up 7 right here. Left 1 up 1 right here. 0 comma negative 1 right here. Now 1 comma negative 1 and 2/3 is right 1 down 1, and well, down almost 2, right? So right 1 down almost 2. Right 2 down almost 2. Right 3 down, oh, it's very close to negative 2, okay? So this function's decreasing, all right? That's why they call this a decay function. All right, and it'll never get below that line. That's why the asymptote, your horizontal asymptote right here, HA for short, is y equals negative 2, because of this right here. There's a connection there. This minus 2 on the function here drops it down 2 units. I can just tell initially, just by looking at the function, that my horizontal asymptote is going to be negative 2. All these values, these y values, are greater than that because they lie above it, right? So my range is y greater than negative 2. Domain, all reals again, because that's the domain for all exponential functions. X-intercept, well, it's kind of hard to tell. So it's between 0 and negative 1, probably negative, I don't know, 0.8. So negative, let me change that. I'm going to have to estimate this. So it's between 0 and negative 1. So I'm going to say negative 0.8 comma 0, estimate, approximately. Y-intercept, well, that's known. That's right here. Okay, that's right there. So 0 comma negative 1, that's easy to see. And the rest is history. Okay, so this is a decay function. It's decreasing. As x increases, y decreases. And so it goes down. It goes in this fashion right here. Y decreases. Y decreases. That's why they call this a decay function and not a growth function, because it gets smaller and smaller and smaller. Okay, let's continue here. Let's see what we got. Okay, another decay function, but we see a plus 1 added to the 1/3 x power, or 1/3 to the x power, but this time we're going to add 1. So I can already see that my horizontal asymptote is going to be at y equals 1, just by looking at this part right there. That affects the horizontal asymptote. But let's prove it. All right, so let's pick a domain. Let's start at negative 3 and let's work it. So 1/3 raised to the negative 3 power plus 1. That is 1/3 raised to the negative 1 power, then cubed, then add 1. And as I said before, you got to reciprocate first, right? So the reciprocal of 1/3 is 3, then you got to cube it, and then add 1. What's that? Well, that's 27, right? 3 times 3 times 3 is 9 times 3, which is 27. So 27 plus 1, total 28. So my first point on my graph is negative 3 comma 28. So 2, 4, 6, 8, 10, 12, 14, 16, 18. Not going to graph that. I'll probably graph the next one. So let's get another point on the graph. So 1/3 to the negative 2 power plus 1. So that's 1/3 to the negative 1 power raised to the second, and then add 1. Pause the video if you can't keep up, okay? For most of you guys, I'm too fast. So pause the video step by step after each point, catch up in your note taking, and see if you can work it out and work one step ahead of me. Pause and play through the video. So the reciprocal 1/3 is 3, and then you have to square it, take it to the power, and then add 1. 3 squared is equal to 9, then add 1, you get a total of 10. So negative 2, 2 comma 10 is on the graph. That we can plot. So you just go left 2, up 10, you're right here. So I'll plot from here on down. Okay. Next one, at negative 1, we have 1/3 to the negative 1 power plus 1. That's just the reciprocal of 3 plus 1, which is 3 plus 1, or 4. So negative 1 comma 4. That was right here. Okay, so I'm plotting as I go. 0, so we have 1/3 to the 0 power, add 1. That becomes 1 plus 1, which is 2. So 0 comma 2 is on the graph. That's a y-intercept. So keep that in mind. That's a y-intercept right there. At 1, we got 1/3 plus 1, which is 1 1/3. That's too easy. So 1 comma 1 1/3. Right 1 up 1 plus 1/3 more. At 2, you get 1/3 to the second power plus 1, which is 1/3 squared, which is 1/9. Add 1, and you get 1 1/9. So 2 comma 1 and 1/9. At 3, you get 1/3 cubed plus 1. That becomes 1/27 plus 1, or 1 and 1/27. So the last point that we have on the graph, and we can plot it now. So I still have to plot the 2 comma 1 1/9. So right up 1 and a teeny bit. Right 3 up 1 and a teeny bit. So I can already tell that my asymptote is y equals 1. I can tell that by looking at this. Y equals 1. That's my my horizontal asymptote. My graph is a decreasing or decay function. Okay, and let's see, domain, all reals. Range, all the y values. Look at this, all these are greater than 1. Okay, so y is greater than 1, and no x-intercept, none. All right, so there's another decay function. Let's take a look at our last one here. Ooh, what's the relationship? Relationship is this: as x increases, y decreases for decay functions. So decay functions are all like this. As x increases, y decreases. It goes down, okay? Look at that. From 10 to 4 to 2, they obviously are decreasing. Decreasing, they go down. Okay, down. All right. All right, last but not least, here we go. Another growth function, base 3. Okay, I already can tell just by looking at this right here that the horizontal asymptote has been shifted down 1 unit, so I'm expecting that. Let's see what we get. So at negative 3, so we have 3 to the negative 3 power minus 1. Rewrite 1 over 3 cubed minus 1. Rewrite 1/27 minus 1. And this is a negative number, so this is negative 1, negative whatever 1 minus 1 to 1/27 is, right? And that's just negative 26 27ths. So my first point in the graph is a number very close to 1. It's called negative 26 27ths. All right, this is a negative number here. So you got to have a negative sign. Small minus big, this is small, this is bigger. Small minus big is always negative. Remember that. Okay, at negative 2, 3 to negative 2 minus 1. Rewrite 1 over 3 squared minus 1. That's 1/9 minus 1, and that's negative 8/9. Small minus big is always negative. 1 minus 1/9 is 8/9, but we get it makes negative because small minus big is negative. So negative 2 comma 8/9 is a point on the graph. At -1, we have 3 to -1 minus 1. That becomes 1/3 minus 1. That becomes negative 2/3. So negative 2/3 here. At 0, you have 3 to the 0 power minus 1, which is 1 minus 1 or 0. So 0, 0 is both an x and y intercept. At 1, you have 3 to the first minus 1, which is just 3 minus 1 or 2. At 2, you get 3 squared minus 1, which is 9 minus 1 or 8. So 2 comma 8. And at 3, 3 cubed minus 1 is 27 minus 1 or 26. So 26 here. So let's plot. So left 3, down almost 1. So left 3, down almost 1. Left 2, down almost 1. Left 1, down 2/3. 0, 0. 1 comma 2, 2 comma 8, 2, 4, 6, 8. So 2 comma 8. 3 comma 26, can't graph it. All right, but I do know that my horizontal asymptote, just by looking at this right here, is y equals -1. All the y values in the function lie above it. It's a growth function. That's why the y values go up. They're increasing. And so it goes infinitely left and flattens out and gets closer to the line. We say asymptotic to the line. The domain, all reals, because you can take 3 to any power you want. Range, well, they're all bigger than -1. All of these right here, the range greater than -1. So range is greater than -1. And growth functions, well, as x increases, all right, y increases too. Look at 2, 0, 2, 8, 26. They're getting bigger, right? They're increasing. All right, look at this. That's why it goes up instead of down, my friends. That's why it's called a growth function, not a decay. All right, now remember, this is a video. So rewind, okay, any part you didn't understand. All right, and watch again. Okay, so remember that it's a video. Take advantage of your resources and use them wisely. And I'll see you in my next lesson. This is Ainsworth signing off.